Hello, algebra. So today we are starting 7.1. I'm going to break this into two different films, okay, two different videos. So we're starting off with how do I find the degree of and identify the parts of a polynomial. So we have right here an expression, right? Equations have equal signs. This is just an expression. All of my orange boxes are variable terms, 7x, negative 5x, 4x, right? And we know that the numbers that are in front of them are their coefficients, so 7, negative 5, and 4. The ones that are in green boxes here are constant terms. So that would be 3, 8, negative 1. Those are all constants. So I know you guys know this. We're just reviewing, helping our brains, right? A monomial is a number, variable, or product with whole number exponents. No fractions, whole number exponents. Okay, whole number exponents. So that'd be like 3. 3 is a monomial, or y, or 4x, or 15abc, or 9x squared, or n to the 56th power, or 11x squared, y to the 7th, z to the 12th. All right, all of those are a monomial. So the next thing we need to do, because we're going to use this later on in order to order monomials, is to figure out degrees of a monomial. So the degree of a monomial is the sum, all right, it's the sum of the exponents of the variables. So if we take a look right here, we can identify, we've got negative 2, a squared, b squared. We know that our coefficient is this negative 2. If we want the degree, what we're going to do is we're going to look at our exponents. Well, for a here, we've got a squared, so it's got a 2, and it says I need to do the sum, and we've got a b. b has a 2 for an exponent. Well, 2 plus 2 is 4, so the degree of this monomial is 4. Pretty easy, right? We know the coefficient is 2, looking great so far. So with this one over here, we have just 4. Well, the degree has to be of the variables, all right, of the variables. I'm going to use a different color. There we go, blue. The variables are the ones that have to have the exponent. In fact, I think I did variables earlier in orange, so I'll change that. So we actually have a variable here. He's a ninja, though. He's a ninja, because we really have 4 times x to the 0. I can always write that, right? We know that x to the 0 is going to equal 1. And I can times anything by 1. It's still whatever it was before. So I actually do have a variable here. He's just hidden. We have to write him in. So when I look at this and I ask, well, what's the degree? We only have one variable in this case, and it has an exponent of 0. So the degree in that case, anything to the 0 power has a degree of 0, right? The degree is adding the exponents together. The exponent was 0, so the degree is 0. Because x to the 0 equals 1. So let's take a look at this guy. Now we've got 8y. Well, there is an exponent here. You have to write him in, because that y is to the 1. So in that case, the degree would be adding our exponents, so it would be 1. All right, so let's try this one next. We've got a 2 and an m to the 1 here, so the degree would be 2 plus 1, which is 3. All right, and that's all we're doing for finding degrees. So I want you guys to take a second, pause the video, and try these ones out. All right, try these ones out. All right, we are going to check out our next page. Whoop, there we go. So polynomials. Polynomials is when we have a monomial or we have a sum or a difference of monomials. So I could have 3y, that's a polynomial, or you could have x squared plus 6x plus 5. That's a polynomial. Or 15xz squared minus 5xz, also a polynomial. All right, each of these is a term. So this right here would be a term, all right? So each monomial in a polynomial is a term. So for standard form, when we're writing a polynomial, we write it so that each term is in order from greatest degree to least degree. Greatest degree to least degree. Biggest exponents when added together compared to smallest, right? So we already know how to find the degrees. So greatest degree to least degree. So when I'm looking at this one here, we've got 3x plus 1 plus 2x squared. All right? I want the one with the biggest degree, the biggest exponents. Well, that's going to be this guy right here, right? He has the biggest degree. His degree is 2. This one has a degree of 1 because it's just an x, right? X always has an exponent of 1. He's a ninja. We don't always see him. And then our 1 here, if you ever have a constant, the constant will always go at the end, all right? Because he's got a degree of 0. Constants always have degrees of 0, as we saw. So when I rewrite this, I'm going to rewrite my 2x squared first. Then I'll do a 3x. Now be careful here. We know that this 2x squared is a positive, but what's this 3x? Is it positive or negative? If it does not have a negative sign written there, then it must be a positive, all right? So make sure you remember, think about, is it positive or negative when you rewrite it? And then we're going to finish off with our plus 1. So that is the standard form of this polynomial. All right, that's the standard form. So let's do this one down here next. All right, let's do this one down here next. So for this one, we have a degree of 0. We've got a negative c to the third power, so this one has a degree of 3. And then we've got 5d to the 3. And then we have, oh, that's a degree of 3, excuse me. And then we have a negative 7c squared d squared. So the degree of this one's going to be 2 plus 2, which is 4. So our biggest degree is this one right here. So I'm going to start off with negative 7c squared d squared. Remember to include that negative, all right? Remember to include that negative because it's a negative 7. The next ones are these two. So I'm going to go with plus 5d cubed minus c cubed. I did that wrong because I cannot do my alphabet for some reason today. So when we have a tie, so to speak, always go alphabetically. So c would come first, all right? Minus c cubed plus 5d cubed. And then we'll finish it off with our 13. What kind of a 13 is it? It's a positive 13. All right. I'm going to slide this up so we can talk about leading coefficients. You should try the other ones on here, okay? Check your work against the key that I have posted. So leading coefficients. The leading coefficient is whatever the first coefficient is when the polynomial is written in standard form, okay? You have to have it in standard form first before you can find the leading coefficient. You have to have it written in standard form first before you can find the leading coefficient. So first thing, we got to write it in standard form. So I am going to find my degrees. We've got just an x for our first term, so that's degree of 1. This one has a degree of 3 because the x has a 3. This one's a constant, 2, so it's just 0. And then our last one here is a degree of 2. So I can see that my biggest degree is this 3, right? So I'm going to start with this guy. So that's a negative 4x cubed. Then we're going to do this one, so minus x squared. Then my degree of 1 comes next, so that would be plus 20x. And then I finished it off with a plus 2. So that's the polynomial written in standard form. Now we have to look and find the leading coefficient. What coefficient is out front of everything? Well, the coefficient that's out front of everything is this negative 4. So the leading coefficient is negative 4. Now, if you had not rewritten it, you might think that 20 was your leading coefficient, but that's not the case. That's why it's so important to do standard form first to find your leading coefficient, all right? We're going to use this a lot coming up for really the rest of the year, is finding our leading coefficients. All right, let's do another one, like right here. All right, so we're going to rewrite this first, standard form. T squared has a degree of 2. Negative t cubed has a degree of 3. And then negative 10t has a degree of 1 because there's just one little lonely t, right? That's his exponent. So when I rewrite this, I am starting with my t cubed. Now here's what's really important. This has a coefficient, all right? And it's hidden in there, but it's a negative t cubed. That negative sticks with a t. Don't forget them at the grocery store. Keep them with you. So that's our first one. Then we would have a t squared. What kind of a t squared is it? Positive. Then negative t, 10t, excuse me. So there is a coefficient to this. He's hanging out there. It's not just negative, though. It's what? Ooh, good question, right? It's a -1. That is our leading coefficient because there is a 1 as a ninja in there, right? He's a ninja. He's always there. You just don't always see him. So try the rest of the problems on this page, write them in standard form, then find the leading coefficient. All right, the next one we're going to talk about is the degree of a polynomial. So we talked about finding the degree of each term, right, a monomial. Now, how do you find the degree of a polynomial? Well, the degree of a polynomial is the degree of the term with the greatest degree. So when you write it in standard form, it's going to be that first term, right? So find the greatest degree, that's the degree of the polynomial. So for our first term here, we've got 4x. That has a degree of 1. And then we've got negative 18x squared. So this has a degree of 2. So when I rewrite it in standard form, I would have negative 18x squared plus 4x. And the degree overall would be 2. That is the degree overall. All right, let's take a look at this one next. It's got some decimals there for coefficients, which always makes it fun. So for our first one here, we have a degree, wrong color, of 1 plus 1. So this would be a degree of 2, because each of those, x and y, there's just one of them. They have an exponent of 1. 1 plus 1 makes 2. For this one, we have a degree of x squared, and the y has a 1. So this is a degree of 3. And then our last one, remember, coefficient, or constants, the other C word that I've talked about today, has a degree of 0. All right, so this one overall would have a degree of 3. If I rewrite it in standard form, it would be 0.5 x squared y plus 0.25 xy plus 0.75. So it has a degree of 3 overall. And we can even say that the leading coefficient would be this 0.5. So there's 4 more on this page. Go ahead and try them out. All right, the last thing we're going to talk about is classifying polynomials. And this is really just kind of, I think it's really interesting, the patterns that we have with polynomials. So we already know if we have a degree of 0, that means it's a constant, right? It's the number 5 or 10 or 32 or 1,075,000. A linear has just a degree of 1. So it would be like 3x or 5x plus 10 or just x minus 1 or just y even. Quadratics have a degree of 2. So it's x squared or y squared or z squared. Cubics have a degree of 3. So x cubed, y cubed, z cubed, right? And then quartics have a degree of 4. So it would be x to the 4th, y to the 4th, z to the 4th, or even x squared, y squared. That would be a quartic as well. Monomials we already know, so the number of terms, right? The number of terms. If it has just 1, it's a monomial. Constants are a monomial because they just have 1. Linears, so when you have y equals mx plus b, that's a binomial, right? Because it's got 2 terms. Trinomials would be if you had like x plus y plus z, and anything that has over 4 we just call a polynomial. So when we're down here, we're going to look at these. We're going to classify each by its degree and then by the number of terms. All right, degree and then number of terms. So the degree for this one, remember we can write an x to the 0, so it's going to have a degree of 0. And then so it's a constant, I should say, it's a constant, right, because it's got a degree of 0. And then it has only 1, so it's a monomial. Oops, excuse me. There we go. Sorry, our meet's about to start. So our next one right here, let's just skip down here. This one has a degree, 7p plus 1. The p has a exponent of 1, so it has a degree of 1. So that means that this is going to be a linear. And then if we look at it, How many terms does it have? Well, it's got 7p and a 1. That's 2, right? 2 terms, so it's a binomial. When we look over here at this one, I'm just going to skip over to 12. We have our first one, 2m to the 4th, has a degree of 4. Negative or minus 7m squared has a degree of 2. Minus 5m has a degree of 1. And then plus 1 has a degree of 0. So our biggest one here is the degree of 4. Degree of 4 is a quartic. It's so fun to say that word. Quartic. And then when we look at this, we have 1, 2, 3, 4. So it's a quartic polynomial. All right, I hope that helps. Please email me if you have any questions.